Hello there, it's Jay here from Jay's Vintage Junk, and we're back on with the Merlin Tonto monitor repair, and I think I've made a bit of progress and I'm kind of kicking myself at the moment. As you can see, I've got it completely stripped down now. I've got the little tripler out there, I've got the scan coils disconnected, I've got the main PCB out here, I've got the neck board off. The reason I wanted to do this is, like I said in the previous video, I wanted to have a look at that electrolytic on the neck board there. And I have pulled that off and tested it, and it's a bit low on value, but it's not leaking, and apart from that it seems okay. And the thing is, when I pulled the neck board off, my shorts disappeared. It looks like all along what my short's been, it's not, well, here's the thing, we definitely had a fault on this board, and that was that capacitor, the first capacitor we took off. I've done a few tests on that cap, and yeah, it does have a value to it. Like I said, I think it's showing up about 1600 microfarad when it finally charges up. It's meant to be 1000. It's badly cracked on the bottom there. What's it, 16 working volts. And if you put, say, 9 volts, 10 volts on it, it breaks down and becomes a resistor. So I'm pretty sure as soon as it saw the 12 volts from the power supply, that's exactly what it did, it just shorted out. When you put a lower voltage on it, it seems okay. So that's basically, I think that's what the fault was. But after that, unfortunately, we've been chasing our tail. This is one of the reasons why I would have really liked a circuit diagram for this, because if I'd had a circuit diagram for it, I would have seen what was happening straight away. And what it is the tube here has a 12 volt filament in it, and basically the heater filament for the CRT is connected directly across the DC input. So when I was measuring for a short, what I was actually measuring was the continuity on the heater. And obviously, because it's a tiny little heater, it's, you know, under an ohm when it's cold. So that's basically what it was. When I pulled the neck board off, I'm getting about 15k between ground and 12 volts, which, as far as I'm concerned, I'm quite happy with. What it does mean, at least, is we have changed all these suspect capacitors, which would have caused us issue sooner rather than later. And like I said, we had to get the board out anyway, because we did have to change that one electrolytic, which was certainly causing, like I said, causing a problem. But if I'd have had a circuit diagram, like I said, I would have seen from the circuit diagram straight away that the heater filament was fed straight off the 12 volt line. I even confirmed, I pulled the data sheet for the CRT out, and on the specs it says that it's got a 12 volt filament on the heater, so that's pretty conclusive. So what I'm going to do now is I'm going to reassemble this thing. I won't bore you with me putting it back together, because it will take a while. But then once I've got it back together, we'll dig out just a basic 12 volt power supply, and we'll try powering the monitor chassis up just off a DC 12 volt supply. And if it's happy then, and we don't get any smoke emitted or anything, then we'll put the known good Alps power supply, which is this the known good one? Yes, this is the known good one. So we'll put this known good Alps power supply in there, and then we can actually get on and test and actually see if the Merlin Tonto is actually going to do anything. So I'll be right back as soon as I've put all these bits back in here. So back in a second. Okay, we've got it all back together. That was a bit of a pain. That's took me about a good 40 minutes to actually get all that back in there and in the correct place. And that bloody tripler, I think it is a tripler there, that little blue thing there, that was an absolute pain in the backside to actually get to sit down and all the bracket to get in, and that was fiddly to do. But as you can see, like I said, I've got everything back in the chassis there, and I've dug out, this is just a 12 volt, like 1.2 amp, yeah, 1.2 amp, 12 volt wall wart. That will give us a little bit of current limiting. I don't expect this to pull more than like an amp or two, to be honest. It's only a tiny little monitor. So what we're going to do is we'll just lash it up to this external source and actually see what happens, to see if we get any magic smoke emitted, or if indeed we can check, see if the filament light's in there. If it does and it's happy on that 12 volts, and like I said, it doesn't even pop the power supply, that's why I'm using this. Mainly because my current limiting power supply is not working at the moment. I've still not had a chance to really dig into it and repair it. So this will do for now. Like I say, if we're happy that it all powers up and everything and nothing nasty happens, then we can put that in it, box it, button it all back up, and then we're ready to actually see if the computer itself is going to do anything. So we really will have to just lash this up as well. I've got some hookup wire here. I'll just cut a bit of a hookup wire off. Where's my snips gone? What's the polarity on this? It should say on it's centre positive. I mean, this isn't recommended or anything. We should really be doing this with a proper current limiting bench supply, but like I said, needs must and all that. Now I really want to get this thing at least powering up so we can see what the rest of the computer will do. Because I was perusing on eBay, as you do, and I actually managed to pick up a couple of wallets full of wafers for this thing. Now, they are not in tested condition, but I don't think they're formatted either. I think they do have the contents on them, what they had on them. And a couple of them are the old welcome wafers, like the initial welcome program that you got with the Tonto, which I would really like to run. I think there's 2 of them in the lot that I bought, so hopefully they'll probably need refelting like a lot of these old wafers do, but if we can refelt them and actually get them so they'll read, we may be able to actually have a look at some of the original like I said, like welcome pack that you got with the Tonto. That'd be quite nice. That'd be quite a fun thing to have a look at. And also it means we'll have to get the micro drives and everything else associated working. But I think I said the first thing we need to do is see if we can get this monitor to do anything. I do feel a bit of a fool that I've spent quite a few hours on this, and all I really needed to do was eliminate the problem, was disconnect the board off the back of the tube. But you know, you live and learn. I say, if I'd had a circuit diagram for it, we wouldn't have been there. We'd have known straight away that was a cause. We'll connect that in there like that. Right, that's nicely lashed up. So we've got a power supply lashed up. We know on this wire here, this is what goes to the no, hang on, we need to, what do we need? We need that one, sorry. This one needs to plug into the monitor board, because I do want to power that board up as well, because that has like a soft start function on it. I think that's what that button there does. So we want to see if that board will fire up as well as the main board. We've already ascertained that there isn't a short on that. So then all we need to do is we want on this connector here, we need to trace out what that orange wire and that purple wire are in relation to these. I think the purple one's fairly easy. The purple one is that wire there. We'll check that with the meter anyway. We will check with the meter because we don't want to make a mistake at this late point. So I think that wire there, which is the third in, is the ground. So if we check that with the purple, which is that wire there, that's 1 down, 2 down. No, let's try the next one along. Oh no. Let's try the next one along. The big purple one. That's it. So that's our ground, is that big purple wire there. Now I think the big orange wire there is our 12 volts. Let's just double check. That should be this one here. And it is. Right. So we're good there. We know which ones are which. So we need that wire there. We'll fold it over. We'll connect that to that purple one there. That's not a very good fit, but it should be good enough for our initial check. And then the next wire we need to go to ground, which is that one right there. And let's just double check we've got them in the right way. So we've got that wire there that goes to the case of the, sorry, goes to the barrel of that plug, goes round, and that goes to the purple wire, which we know is ground. The centre pin of there goes along, and that goes to that orange wire there, which we know is our 12 volts input. So now when I plug this into the socket I've got under here, hopefully we shouldn't get anything blow up on the monitor, and with any luck these should light, and we should be able to see, if I turn the extra light out, I should be able to see the filament glowing in the back of the CRT. So let's have a try. So we're ready for a pop and a bang. Let's see. Well, we've not had a pop or a bang yet. That's powered up. No signs of life either. Let's just make sure we've got a good contact here. Yeah, I think we have. Yeah. Let's get the meter and see if we've got any. I'll just unplug that for a second. Let's get a meter and see if we're getting anything. Perhaps that power supply is actually not powerful enough. I have got another one here which is a 2 amp supply. That should be plenty, because the board itself, the actual power board, only produces about 2 amps on the 12 volt rail. Obviously there's things in the computer, I presume, that also use that 12 volts. Alright, so let's have a look, make sure that we're actually getting some voltage. Sit that way you can see it. I think you can see that there, can't you? Let me zoom you in a little bit. Ooh, there we go. And we'll see if we've got our 12 volts going in. Put the leads in like that. We'll plug in and see what happens. Oops. Is that still connected? No. We'll get this reconnected and then we'll plug in and see what happens. We'll connect that in there like that. So it's not ideal doing it like this, but with the absence of my... Oh! There we go. I don't know what that's showing. But do you see we got power LED lit that time, so I wonder if we just had a bad connection. Let's set that to 200 volts DC, because we know we're nowhere near that. Let's try connecting that up again and see what happens. Well, nothing there, but we did before just definitely get power LED on there, and that's not anything we've had on before. There we go. I think there's something very wrong with my tester there, because that's showing... Oh, hang on. But our LED is lit. Not getting anything else to power up, but that's encouraging. and we haven't got any smoke or anything. I think I'll unplug that. But obviously, the way we've got this thing hooked up at the moment is not ideal. Yeah, better if we could get a better. In fact, I'll just pause you for a minute. I'll just see if I can connect this up in a bit of a better way, because it's not ideal the way we've got this lashed up at the moment. I think we're getting a bit of a bad connection somewhere. But we've certainly, for the first time, saw at least some signs of life from the monitor. And so far, we've not seen anything go pop. So I'll be back in a second. Okay, we seem to have another issue. I've just been messing about with it. I've had it powered up for a little while now, taking some voltage measurements, and this that's basically your power on. I believe that's your power on indicator. I think it says on. Let's have a look on the front. Yeah, that's your power on indicator there. There's your monitor on indicator. Basically, you should press that button there, and that should light up, I believe, and then the monitor should power up. The problem is, I think that switch there is actually dead, and it's a bit of an odd switch. Basically, it's a 3-pin push switch, and it's dead short. I've tried between centre and that side, right across, and every pin is short. I mean, you get push to break switches. That's not an issue, but pushing it causes absolutely nothing to change at all. So I have a feeling that the contacts inside there have stuck or something like that. So I'll try a bit of contact cleaner on that, see if we can free it off. But if not, that could be a bit of a problem, because like I say, it's not like just a normal push switch. It's got three elements in it, really. You've got a centre and two other pins, and I don't know how it's connected. All I can see at the moment, just testing off it, is that it's dead short. So I think what we're going to have to do is we'll have to pull this board off and have a look at that board. I suppose I don't know, could we bypass? No, I don't want to risk that. I was going to say, could we bypass all this and just put some 12 volts to the monitor and see what the actual with the monitor board will fire up, because it should do, and we might even get a bit of a raster on the screen. But let's see what we can do about this first. So I'll just pause you again, and we'll get this board off, and we'll take a look at this board, and we'll see what we can come up with from there. So be right back. Okay, we've got the board out, and that was an absolute pain. I don't know if you've ever come across these before, but these are exactly the same kind of fixings that the original Sinclair ZX80, the white Sinclair ZX80 basically used to hold the two halves of the case together. And anyone that's worked on one of them knows how much an absolute pain these things can be, because they have a tendency to snap and break. Fortunately, like I said, I've managed to get them all out, but that's what was actually being used to hold the board on the actual front of the monitor. And I've just checked it again, and the short's still there. Basically, that switch there is completely shorted out. And I've just checked basically we've got two big traces coming off it, and then we've got a much thinner trace down here which comes off, and I think it goes to one of them resistors down there. It's obviously some kind of sense pulse to do something. We've not got a lot on here really. It's mostly resistors and diodes. We've got that one chip there which I mentioned in a previous video. It's weird. It's like one transistor array and then 3 transistors all put into one little package. And I was wondering whether it's what's being used to combine H-sync and V-sync, and then perhaps boost the RGB lines. I don't know. I really don't know how that. I could at least combine the RGB lines. I don't know. That's what I'm suspecting that's possibly being used for. We've got another transistor there. But I think what the next thing's going to be is I'll have to take that switch actually off here and test the switch out of circuit. Ascertain whether it's the switch that's at fault or whether we've got something on here which isn't happy. Because as we've said, like I said, I don't think we should definitely have a dead short on that switch. So I'll get the old soldering iron heated up. I'll whip that switch off the board, and we can test it out of circuit. If it turns out to be the switch that's at fault, that's going to be a lot of fun. We might have to see if we can strip that down possibly and repair it. Come up with some kind of solution, but it's always some kind of either push to make or push to break switch that switches two different elements inside. So yeah, I'll be back very shortly once I've got the old iron heated up and we can get this switch out of here. So back in a sec. Okay, well I've managed to get the switch off the board, so let's test the switch and find out whether there are faults on the switch or whether it's on the actual PCB. I'm actually hoping it's on the PCB rather than the switch, because it should be easier to fix a fault on here than it is going to be fix a fault on that printed circuit board. Let's test the switch now. We've got it out of circuit anyway. Well, the short's not on the switch there, but the switch doesn't seem to be very happy either. I'll try connecting there to the centre. No, that switch is not happy at all. It's not registering any presses at all, so unfortunately it does look like we've got a faulty switch. Let's just check the board, see if we've got any shorts on the board as well. This thing's definitely got multiple faults. It looks like we've got a short on the board as well. You see the tester there, you can see the tester, can't you? If I go basically across the two thick traces here, we get a dead short there. If we go across between any of the others, no, they're open circuit, but like I said, we go across them two, we've got a short there. And those go to various pins on here. That might actually be right. It might just bring different grounds together when you actually press the switch. But that's by the by. The problem is that the switch is faulty. I will endeavour to see whether I can get something to replace this with. If not, I might have to see whether I can disassemble. It doesn't look an easy one to disassemble. In fact, it looks a very hard one to disassemble. There's some little tabs on there, but I'm pretty certain if I get this thing apart, I'll never ever get it back together. Like I said, I will have a look in all my stuff, see if I've got something we can possibly replace this with. But I think I'm going to leave it there for now. Like I said, at least we've ascertained that we put some 12 volts on here and at least nothing blew up. We did get the power light to illuminate on it, the LED down there when we fed 12 volts in. But I think without that switch, we're not going to get the monitor to come out of its standby mode. Because basically that's what happens with these, from what I can gather, is you put power to them, it powers the Merlin up all the time, and then you press that to bring the monitor out of a standby, and the monitor will stay on while you're using the computer. If you don't touch the keyboard or anything for, I think it's something like 10 minutes, the monitor switches off, and you have to press that button again to bring the or a key on the keyboard to bring the monitor back out of standby and bring it back on. So it's more complicated than just a standard monitor, but I believe this is the board that actually does all that. Obviously in conjunction with the Merlin, but none of that's going to happen with a faulty switch. So like I said, I'm going to leave it there for now. Hopefully in the next video we'll have sorted something out for that switch. We can get it back together, and I think we'll probably we'll put the proper board in, and we'll actually finally see if we can get this monitor to do something. So I'm going to leave it there for now. Hope you enjoyed this little update on the project. So thanks for watching, and goodbye.